Assalamu alaikum, dear brother and sister. Today we are going to discuss one of the most important, astonishing and at the same time terrifying technology of the 21st century, quantum computing. You may have heard this term, but what exactly is a quantum computer? How does it work? And why is it so astonishing and terrifying? What are its future possibilities and risks? Keep watching this video because by the end of it you will find answers to these questions, inshallah. Let's start with the basics. What is a quantum computer? A quantum computer is not just a faster version of your laptop or smartphone. It is an entirely different kind of machine that processes information using the principles of quantum mechanics. The computer or mobile device you are using to watch this video work with bits. A bit can be either 0 or 1. Everything from your Facebook feed to high graphics video games is based on these zeros and ones. However, a quantum computer uses qubits, short for quantum bits. This is where the fundamental difference between quantum and classical computer lies. A qubit can be 0, 1 or both at the same time. This is called superposition. It's like a spinning coin. While it's spinning, it's neither just heads or tails. It's essentially both until it stops. A qubit can exist in multiple states simultaneously. But why is this important? Because it allows a quantum computer to evaluate many possibilities at once. While a classical computer solves problems step by step, a quantum computer can solve them simultaneously. This makes quantum computers extremely powerful for certain types of calculation. Now let's talk about how quantum computers actually work. To create qubits, scientists use tiny particles like electrons or photons. These particles are controlled under extreme conditions, such as cooling them to nearest absolute zero, the coldest state of the universe. A key feature of qubits is entanglement. When qubits become entangled, the state of one qubit directly affects the state of another, no matter how far apart they are. Einstein called this spooky action at a distance, and it's one of the reasons quantum computers are so powerful. An example might make entanglement easier to understand. Imagine two Majorana particles being entangled. We will discuss what Majorana particles are in a moment. If one of these entangled particles is placed on Earth and the other near our star, the Sun, you will notice that influencing one particle instantly affects the other. We know that light takes about 8 minutes and 19 seconds to travel from the Sun to Earth, and we also know that nothing in the universe moves faster than the light. So how are these two particles communicating so quickly? This is the magic of quantum mechanics. Essentially, at the quantum or subatomic level, most of the scientific laws of our visible world do not work. Now let's talk about the future challenges of quantum computing. Quantum computing is not always easy. There are significant challenges that must be overcome to make it a reality. First, qubits are extremely volatile. Any minor disturbance, such as heat or vibration, can cause errors in the result. This is called decoherence. Second, as the number of qubits increases, so does the system's complexity and the likelihood of errors, which is a major challenge. Another complexity is that the error rate in quantum computers is much higher compared to the classical computers. Quantum algorithm and software development is also a challenge, as quantum computing is entirely different from traditional programming paradigm. We are still in the early stages of this technology. For most tasks, we still depend on the classical computers. However, that doesn't mean progress in quantum computing has stopped. Tech companies like Google, Microsoft and IBM are making significant advancement. Google claims that its quantum computer Willow performed a calculation in 5 minutes that would take the world's most powerful supercomputer 10 septillion years. 10 septillion is 10 followed by 24 zeros, a number larger than the age of the universe. Meanwhile, Microsoft claims to have developed the world's first topological quantum computer, Majorana 1. It is named after Majorana particles, which are unique because they act as their own antiparticles and represent a completely new state of matter. Majorana 1 is expected to be capable of handling 1 million qubits simultaneously. In comparison, Google's Willow had only 105 qubits. While Google's quantum computer can perform in 5 minutes what the most powerful supercomputer would take 10 septillion years to do. It's hard to imagine what Microsoft's Majorana 1 with 1 million qubit could achieve. Although these claims are still debated, they demonstrate how rapidly the field of quantum computing is advancing. So what is the future of quantum computing? Experts believe we are moving closer to practical applications of quantum computing every day. The day it becomes practical, it could revolutionize industries like finance, cybersecurity, artificial intelligence, and even climate modeling. If quantum computing is applied correctly, it could lead to a world where we can predict natural disaster with precision, design drugs and solutions for deadly diseases like cancer, AIDS, Alzheimer's, and thalassemia more quickly, or create unbreakable encryption to protect our data. However, the realization of quantum computing also carries some terrific possibilities. For example, all online information could be hacked because a powerful quantum computer could break any encrypted code. This could threaten the global economy, cybersecurity, nuclear weapons, and state and institutional secrets. Many are already storing encrypted data from important institutions, hoping to decrypt it in the future using powerful quantum computers. This is called encrypt now and decrypt later. It is believed that quantum computing operates in another dimension or parallel universe, where reality is entirely different from ours. If this technology becomes a reality, we might be able to communicate directly with beings from other dimensions. This is both a source of fear and possibilities. The US National Institute of Standards and Technology (NIST) has developed new algorithms that may prevent future quantum computer from decoding or decrypting data. Quantum computing is still in its infancy, but it is one of the most significant topics in science and technology. It reminds us that the universe is far more fascinating than we imagine. If you enjoyed this video, please give it a like and subscribe for more content like this. Share your thoughts in the comments below. Jazakallahu khairan.